Eg9. A mass of 6 kilograms rests in limiting equilibrium on a rough plane inclined at 30 degrees to the horizontal. Find the coefficient of friction between the mass and the plane. Okay, so now we're moving into inclined planes. So here's my inclined plane. Here's my mass. It's got a mass of 6, so it's going to have a weight of 6g acting downwards. The normal reaction acts perpendicular to the plane, which gives me my 30 degrees inside there. If it's going to move, it's going to move down the plane. So friction will act in that point. So in lim equilib, which means it's on the point of sliding. If it was to move, it would move down the plane so the friction acts upwards. So that means I am going to take this direction to be positive x and this direction to be positive y. We get our equations. So in the x direction, 6g, this is on the inclined plane, so the horizontal component of that, or the parallel component of the plane, is opposite the 30. Remember when we were practicing that? So we got 6g sine 30 minus f equals 0. Then perpendicular to the plane in the y direction, I have my normal reaction minus 6g cos 30 equals 0, and then I've got that my F max equals mu times the normal reaction. So those are my 3 equations available to use. I'm trying to find the coefficient of friction, so I want to find mu, so I need to end up in this equation, and I can see that I get F from there. So from 1, F is 6g sine 30. From 2, I get N is 6g cos 30. And in 3, mu will be F over N, which will be 6g sine 30 over 6g cos 30. The 6g's cancel, and sine over cos equals tan. So that will be tan of 30. So tan of 30, which has got the third form, which you couldn't see then, of root 3 over 3. And because the g's cancelling that, we can leave that as in its fractional form. So that's Eg9.